Okay, so here we're going to talk about when we have more than one springs connecting together. There were two basic cases. The first case, number one, is called when two springs connect in series. So we assume by definition, we know the spring constant K equals to the force you applied divided by the deflection. So let's look at this case. We assume that there is a force applied on the left, and then this force is F. And because K1 and K2, they're connecting in series, so that means the force experienced by K1 is F, the force experienced by K2 is also F. And then for each spring, the deflection is force divided by spring coefficient. And the total deflection is going to be the summation of delta x1 plus delta x2. So that we have F over K1 plus F over K2. And then we can plug this delta x back into the definition. And we have F divided by 1 over F over K1 over F over K2. And then we can easily cancel out the F, and then it becomes 1 over K1 plus 1 over K2. So that means when you have two springs connected in series, then the total spring coefficient is just following this equation. Alright, the same thing, we can use the same concept to calculate the effective spring constant when two springs connected in parallel. The same idea, you have force divided by delta x. So assume that, again, we're fixing one end, we're applying a force F on one side. Because these two springs are in parallel, in this case, the deflection of each spring is the same. So we have a delta x and delta x for both spring deflection. So if the first spring divided by delta x, then the force experienced by the first spring is K1 times delta x. And then the second spring experience a force of F2, that's K2 times delta x. And then the total force we applied is going to be the summation of these two small forces. And then we have K1 plus K2 times delta x. And then you can replace the F in this equation, that is K1 plus K2 delta x over delta x. And then we can cancel the delta x out. We have K1 plus K2. So that's the equation you need to remember. So when two springs connect in parallel, that's the effective spring constant we get.